Welcome to the Nokia SR Linux Learning Essentials video series, brought to you by the Nokia Data Center Fabric Certification Program. This video explains SR Linux debug trace options configuration for troubleshooting. SR Linux logging for debug purposes is based on Linux rsyslog. To limit the number of log messages and the associated CPU overhead, the debug priority works in conjunction with the trace options that are enabled at an application level. Traced options are currently available for a wide range of SR Linux applications and will be added for additional ones in the future. The source of debug messages can be SR Linux hosted server applications such as DHCP, RPC, or Netcom servers. It can also include the system or protocol applications such as LDP, BGP, ISIS, or OSPF, the IGMP or PEM, as well as the sub-interface DHCP capacities, and the ARP and ND proxy tables. SR Linux provides a debug message logging based on the syslog output format. The trace options context differs depending on the application. For BGP, it is possible to log all protocol messages or focus on a given BGP group or neighbor. Let's now go to my DCF Learning Lab and enable the logging of debug messages for the BGP subsystem. To generate debug messages, the trace options must first be enabled and configured at the application level. In this BGP example, the trace options flags allow users to filter messages of interest, such as BGP keep alives, packets, events, timers, notifications, and others. The modifier allows further filtering to include only received packets, only sent packets, or detail on packets as configured here. Let's also add the keep alive flag to capture BGP keep alive messages, with the detail modifier as well. That's it. Do commit to stay in edit mode. Now we need to configure a buffer log for the BGP debug messages. Do commit and exit the edit mode. You can do show system logging to list the default and the configured logs. The new file is stored under the SR Linux buffer folder. Let's now check the last 10 messages in the BGP debug buffer. In the log, keep alive packets are received from and sent to the three BGP peers, Leaf 2, Spine 1, and Spine 2. As a final test, let's trigger some BGP packets. Log into Spine 1 and run the following tools command to reset the BGP peering with Leaf 1. Back to the Leaf 1 node. Verify that the BGP debug buffer records the expected events such as BGP update messages. The logged information includes full details of the exchanged messages, which is very useful for troubleshooting potential BGP peering issues. That's it for SR Linux debug trace options. Thanks for watching and be sure to explore the rest of this video series to learn more. And when you're ready to practice what you've learned, my DCF Learning Labs provides comprehensive exercises with step-by-step instructions and solutions, all in one simple browser-based application.